Okay, so let's continue our journey here in the unit circle and see where we can go with this. One of the interesting things about the unit circle is it actually has a really important use. The important use for it, yeah, trig ratios. And they're going to allow us to figure out the exact values of these trig ratios. That's the thing that's really, really cool about the unit circle. We'll get into that in upcoming podcasts. Hang tight. Let's just go through the basics first. Now, is there anything else that we learned in Math 20-1 that's going to help us out? Well, yeah, special triangles. Do you remember those guys? The 45, 45, 30, 60, 90. Do you remember them? I do. Look, here's the 45, 45. And if you know anything about a 45, 45, you know that this side and this side match. They're exactly the same. So you see the ticks? You see the ticks that I just put down? They look like the number 1, doesn't it? Well, that's great. Use your a squared plus b squared equals c squared to find out this value. Your piece of cake. 1 squared, 1. 1 squared, 1. 1 plus 1 is 2. Square rooted, there's the root 2. That's how we figured it out. Now, for this one, it becomes a little funny because what happens is always, I like to put my right angles on the right, but think about it. The 60 degrees sinks to the bottom, the 30 degrees floats to the top. That's how I remember it. 60 is heavier, 30 is lighter, right? And then count to 3. 1, 2, 3. But the problem with this is 2 is your hypotenuse. And guess what? If 2 is your hypotenuse, then sports fans, this can't be 3. So square root it. Okay? It's a little dance that I did in class here for you guys last year. I don't know if you remember that or not. Okay. Anyways, let's go on. I want to show you something else that's pretty unique about this. Now, do you have to memorize this? Honestly, I would say yes. But I'm going to also show you something else that's neat. Because if you are smart and you say to yourself, oh, well, okay, well, wait a second here. I want to make this into a unit circle. How does the unit circle get into this? Okay, well, watch this. I'm going to put my unit circle looking like this. This is now the radius of the unit circle. But wait a second. If we're talking the radius of the unit circle, what must the radius be? The radius has to be 1. Guess what? This is not a unit circle. That radius is root 2. How do we make it 1? That's the question. Okay, easy. Divide everything by root 2. Divide it all by root 2. Divide it all by root 2. Watch this. Root 2 over root 2 is actually 1. This is now 1 over root 2. That's now 1 over root 2. They still match. Everybody's happy, right? Now, the thing about 1 over root 2, though, I have to do a little bit of an aside here because 1 over root 2 is not particularly loved. You don't put a radical in the denominator. You have to rationalize this. So in the math world, you actually put this as root 2 over 2. Works out to be the same. Do you remember how to rationalize those radicals? Yeah, that's how you do it. So you now have a really pretty looking number in the denominator. You can't have a radical in the denominator. They don't like that. So I'm going to remember this as root 2 over 2. This one is root 2 over 2. Got it? Okay, that's important. Now, take a look at my next one over here. Take a look at this one. If I put a coordinate axis on this, check this out. Look at this. My radius is 2. Not a unit circle if you do that. So what you have to do is you divide this by 2, making it, guess what? A 1. But you divide everything else by 2, making this a half, making this root 3 over 2. Now you're probably saying to yourself, well, what does that have to do with anything? Well, I'm going to show you something here. Think of all of the angles that we just talked about. The angles we talked about in this triangle are 90 and 45. The angles we talked about in this triangle are 90, 30, and 60. Those are the specific angles that we're going to use most in Math 30-1. The 30, 60, 90, and the 45's in there as well with the 90, and the multiples that go along with them. Oh, okay. So the special angles then are 30, 45, 60, and 90, and include the 0 in there because that's where we're going to start, right? So how do we do this now in radians? Well, I'm going to give you the radians right now, for now, but in the subsequent podcast here, I'm going to show you how to figure out the radians, and that's going to be the best part. It is so easy that you could just stare at a circle and you can figure it out right away. Okay, so what does this end up doing for us? Well, what it ends up doing for us is something really incredibly valuable. It ends up giving us the points on the unit circle. You're thinking, what? What? Okay, let me rewrite this, and I'm going to show you something very, very cool right away, okay? I'm going to rewrite our triangles. So first one I'm going to rewrite is I'm going to rewrite the 45 one as a unit circle, okay? So that's going to have a radius of 1, okay? So this guy here then is going to be root 2 over 2, root 2 over 2. We know that that angle is 45 degrees. Got it? Look at the other one now. Take a look at this one. There's our 60 degrees. There's our 30 degrees right angle, right? Watch this. This is now 1 because we want it to be a unit circle. This is root 3 over 2. That's 1/2. Now, check this out. What does this mean now on the unit circle? Well, let me show you. Check it out. If I was at 45 degrees on the unit circle, right? There's my radius of 1. 45 degrees, well, there's my nice special triangle, the one I just drew right here, but flipped. It doesn't matter, okay? So think about it. What's this height? This height is root 2 over 2. What's this length? Root 2 over 2. So what's the coordinate of this point? That coordinate of that point is root 2 over 2, root 2 over 2. Oh my goodness. This special triangle now, because we made the radius 1, is allowing us to find all kinds of points on the unit circle. Oh my goodness, you've got to be kidding me. No, I'm not. As a matter of fact, I'm going to show you a couple more things about 45, which is going to freak you out, right? Let me just clean this guy up. Let me show you. What's really, really cool about the 45 is that, look, if you make a box like this, all the way across, right? Like this. Every coordinate on this circle is now root 2 over 2, 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 root 2 over 2. The only difference is the directions, the positives and negatives. This is a positive root 2 over 2 to the positive root 2 over 2. These are both positive. This one is negative root 2 over 2, positive root 2 over 2. There's your coordinate. Okay? Think about this one. Negative, negative. Wow. Cool. Think about this one. Positive, negative. Oh, guess what? I didn't just give you the coordinates of 45 degrees. I gave you the coordinates of a whole bunch of angles. What angles are we talking about? Think about this. That's 45 degrees, meaning that that's a radius of 1. That's 45 degrees. I just gave you the coordinates of from here to here, right? Because that's your reference angle. Oh my gotcha. So I gave you the angle. I gave you the coordinates of 135 degrees. Oh, I know, isn't that just incredible? Look at this now. This is so cool. If I extend this out as a 1, look what I just did. I gave you the coordinates, so I went past 180, went another 45 because that's our reference angle. I just gave you the coordinates of 225 degrees. And 225 degrees is minus root 2 over minus root 2 over 2. Check it out. We have one more to go. Look at that. Look at that. Going all the way around now to this point, which if you think about it, there's my reference angle of 45 degrees, making this 315 degrees, and the coordinates of 315 degrees are positive root 2 over 2, negative root 2 over 2. Thank you. Okay? Isn't that wild? It's so incredibly cool. You can do the same thing to this guy now. Check it out. This becomes so amazingly powerful. Watch. Look. 30 degrees. 30 degrees. Think about it. We had a 60, 30, 1, 2, root 3. You divided everything by 2. right, to make this a 1. Now, look at this. We're at 30 degrees. 30 degrees means we're right here. Across from 30 degrees is a half, just as I have written in the diagram. Adjacent to 30 degrees is root 3 over 2. So watch this. This is going to freak you out. This is for 30 degrees. Watch, watch. I'm going to draw a box again to every one of the coordinates out here. So check this out. This is now reference angle 30 degrees. This is now root 3 over 2, 1/2. This now is root 3 over 2, 1/2. This now is root 3 over 2, comma, 1/2. But before we make them coordinates, we better have the signs down properly. Going in that direction is a negative. Going up is a positive. Going that direction is a negative, negative. Okay, there's the coordinate for that one. Going this direction is a positive. That direction is a negative. But I got another question for you. Since this is related to this triangle, can't I do the same thing for 60 degrees? You betcha, baby. Check this out. There is 60 degrees. Look at that. Right up to there is 60 degrees. Check it out. I can make all the 60-degree ones now. All the 60-degree ones all the way through based on this reference angle of 60 degrees. So think about it. What's opposite to 60 degrees? Well, that's going to be root 3 over 2. So there's root 3 over 2. Isn't that a y coordinate? That's a y coordinate because you're going up. The x coordinate must be 1/2. So this point here is just the flip of this. This is 1/2 root 3 over 2. This is going to be 1/2 root 3 over 2. Right? This is going to be 1/2 root 3 over 2. That guy over here is going to be 1/2 root 3 over 2. But again, we have to put in the proper signs. This sign is positive, positive. This sign is negative, positive. This sign is negative, negative. And then this side is positive, negative. Look at that. Look at that. I just have the coordinates for all those values. Well, what are those values, though? Well, guess what? That's going to be 60 degrees. And then what's the next coordinate then? That's the puzzler. Well, if you think about it, that's 60 degrees, making this, guess what? 120 degrees. Making this out here, think about it. That's going to be 200 and, you got it, 240 degrees. That's going to be 240 degrees. What about out here? Well, think about it. Isn't that going to be 300? Why? Because the reference here is still 60 degrees. 360 all the way around, back 60 degrees gives you a reference of 300. What a mess! Oh my goodness. So that's why I'm going to give you this. Check this out right here. Okay? Come on, thing. Look. There's all the special triangles written in just beautifully for you. Okay? 30 degrees. Look, there's your 30. Right? There's the coordinate for it. Root 3 over 2, 1/2. Why? Because to go over to here is root 3 over 2. To go up is 1/2. That gives you the coordinate. Look at the next one. 45. Remember, the two sides had to be equal in a 45, 90 triangle. Sure, they're equal. There they are. Look at this. There's your 60 degrees up here, which is just the flip of this because they come from the same special triangle. So you're going to go out 1/2 up root 3 over 2. There's the coordinate. But what did these coordinates mean? These coordinates meant 30 degrees, 45 degrees, and 60 degrees. And what I'm going to teach you in the next podcast here, which is the coolest thing, is that this is pi over 6, this is pi over 4, this is pi over 3. That's what the coolness factor is on all of this. Oh my gotcha. It's going to just absolutely smoke your world. Stay tuned.